that technology allows us to do this. It's a great privilege for me to teach this class, and I hope that you're enjoying it. Tonight, we're going to talk on this subject, what the eye can't see. And again, this falls into a pattern of discussions that we have about the role of theology and natural science in our modern world, and how, in fact, largely due to revelation through Joseph Smith in the latter days, these two subjects that sometimes find themselves at odds have come together in beautiful new ways. So let's discuss together tonight a little more about that. But to begin with, I've got a little quiz to offer. Don't be afraid, this isn't for credit, this is just for fun. Here's the question, I'll give you a few seconds to think about it. How many stars are there in the known universe? This is a good review from our talk last time.
Potete rispondere su un pezzettino di carta, poi il professore Anziano Lamb vi darà la risposta dopo, quindi rispondete come potete, ma non dovete mandarle da nessuna parte la risposta, la tenete per voi.
No, and in fact, this is just more or less to help remind you of what we learned in our last lesson. Is answer C. There are more stars in the known universe than there are grains of sand on all the beaches on the planet Earth. And in fact, you'll probably remember that we could throw in all the grains of sand in all the deserts as well. It's just an astonishing, amazing number. And it's a great testimony of the power and glory of our Heavenly Father and the wonders of his creations, isn't it? You'll recall that we discussed last time that there was an apparent conflict in Joseph Smith's day between his revelations and what science was teaching. He was teaching, Joseph Smith was teaching through his revelation, specifically in the Pearl of Great Price, that there are millions of Earths like this, whereas science was teaching that there is one Earth, one known Earth at least, in one solar system, in one galaxy with an indeterminate number of stars. And you'll recall that last time we resolved this problem. Over the last couple of hundred years, science has kind of caught up with Joseph Smith in the sense that science now recognizes that indeed there are probably millions of inhabited worlds in the universe, if not more. So the resolution came about this way. Scientists now affirm that there are trillions upon trillions of stars in billions of galaxies and many, if not billions, of habitable planets out there. An amazing, wonderful thought. Well, today we're going to talk specifically about belief in the unseen. And our objective in this lecture is to demonstrate that science asks us to believe in the unseen as much as religion does. And that has not always been the case. Over the millennia, we have relied, human beings have relied on our 5 physical senses to learn about and understand the world around us. And in Joseph Smith's day, there was an apparent conflict between theology and natural science in the following sense. In religion, we have faith, don't we, in the existence of an unseen God, a spirit world, angels, and other things. Whereas in Joseph Smith's day, science was pretty much rigid on the idea that if I can't sense it, it doesn't exist. In fact, we talked last time about how Joseph Smith was born and grew up just towards the end of a period in intellectual history that we call the Age of Enlightenment. It was an age in which people felt that human beings were had the right to judge what's right and understandable and true about the world, based on the idea that what we can observe with our natural senses gives us a true picture and a complete picture of what the world is made of. At that time, scientists, like astronomers, were still using their natural eyes to look at things. Yes, they had begun to use some machines like telescopes and microscopes to expand their vision, to expand the vision of human beings into the natural world, to come to understand it better. But we still relied on our natural eyes to look at the world and understand it. Now, Joseph Smith and others at the time were teaching that there are aspects of reality that we can't perceive with our natural senses. Here's a quote from the teachings of the prophet Joseph Smith, for example. The righteous and the wicked all go to the same world of spirits until the resurrection. So we believe that, in fact, when we die, we don't just disappear, we go to another world, a world of spirits. Where is it? Well, it must be around here somewhere, but we can't see it or perceive it with our natural senses. And he went on at another place to expand a little bit on this idea. He said, the spirits of the just are exalted to a greater and more glorious work. Hence, they are blessed in their departure to the world of spirits. Enveloped in flaming fire, they are not far from us, and know and understand our thoughts, feelings, and emotions, and are often pained therewith. Brigham Young was even more clear on this question. Brigham Young, of course, the prophet who succeeded Joseph Smith. He said, where is the spirit world? It is right here. Do spirits of the departed go beyond the boundaries of the organized earth? No, they do not. Can you see it with your natural eyes? No. Can you see spirits in this room? No. Suppose the Lord should touch your eyes that you might see. Could you then see the spirits? Yes, as plainly as you see bodies. Well, this particular controversy reminds me a little bit of Lehi's dream in the Book of Mormon, where there is this great and spacious building on the other side of a chasm, and the people in the building are making fun of those who believe in and follow Christ and the gospel. And you can imagine them saying something like this, haha, you actually believe in invisible spirits? Well, of course, they would say, we don't, of course. We don't believe in things that we can't see or perceive with our natural senses. And that was kind of the situation in Joseph Smith's day, wasn't it? What about today? What does science have to say today about the possibility of the existence of things that we can't see? Well, since I'm a chemist, I thought it would be interesting to start with one of the fundamental beliefs of chemists and scientists, and that is belief in the existence of atoms, that atoms make up the world around us. Of course, this belief over the last couple of hundred years has produced a lot of very useful and wonderful things that make our lives more comfortable and safe. Chemists can take a vow that because of this belief, they have come up with a lot of these. And the hope is that future generations of chemists will provide us with even more wonderful products that will make our lives more enjoyable. But the question arises, is there any doubt, or has there in the past been any doubt that atoms actually exist, that the world is made of atoms? Today, you've probably been taught in school that atoms are a fact. There's no doubt at all. And you've probably known since childhood, since early childhood, that atoms exist. But I have a question for you. Has anyone ever actually seen an atom? Let's look a little bit at the history of atoms, the idea that the world is made of atoms. If you pick up an object that's nice and smooth, like a piece of glass, like you see here, and you run your hand over the glass, it doesn't feel grainy to your touch, does it? So it's rather unusual to think that 2,300, 2,400 years ago, Greek philosophers decided that in order to explain how the world works, it must be made up of very tiny particles, even though we can't necessarily see them or even feel them with our fingers. Democritus was one of the scientists who proposed that the world was made of tiny atoms in about 400 BC. We've talked about him before. But to recall, I wanted to mention that the word atom, by the way, was invented by the Greeks. It simply means uncuttable. The prefix "a" meaning not, and tome having to do with cutting. You'll probably recall that this idea didn't last very long. It wasn't long after Democritus and his fellow scientists passed on that this idea about the world was replaced by a simpler idea. It was the idea of Aristotle that the earth, the materials in the earth, are made up of 4 elements: earth, air, fire, and water, and that the material that made up the heavens was a 5th material called the quintessence. We talked about that in a previous lecture. As you'll recall, a lot of time went by before the ideas that Democritus had come up with began to be considered again seriously. And in fact, it was in the early 1800s, along around the time that Joseph Smith was growing up in England, that atoms were proposed again. And since that time, since the early 1800s, scientists have acted for well over 200 years as if we knew that atoms exist without actually really seeing one. Why is that? Well, there are a couple of really good reasons. Over time, scientists were doing experiments, observing the world in ever more sophisticated ways, and they found that everything they observed was consistent with the idea that the world was made of atoms. Furthermore, by using the theories related to atoms and the structure of atoms, they were able to develop all those wonderful technologies that I talked about earlier. Now, after 200 years, the idea that atoms exist has become virtually unassailable, unquestionable. And scientists and people in general have faith that atoms really do exist. Now, scientists don't typically use the word faith in such situations. They might say, we have confidence that atoms exist, but it's really just a matter of choosing your words, isn't it? It really is faith. What is faith? Well, we know from the scriptures a good definition of faith. This from Hebrews, Paul said, or probably Paul, the writer of Hebrews, he said, now faith is the substance of things hoped for, the evidence of things not seen. Notice that final phrase. It's evidence of things that you can't see, but that you have evidence they must be there, they must exist. So even then, Paul was asking us to rely not just on our 5 physical senses, but other ways to understand and observe what the world is really made of. In a different version of the Bible, a more modern translation, the same verse is translated, now faith is confidence in what we hope for and assurance about what we do not see. There's that word confidence again. So in science, we may say we have confidence, and in religion, we may say we have faith that something exists. In science, maybe atoms. In religion, maybe God or the spirit world. But in both cases, this confidence or faith starts out small. In the case of atoms, it started out with a proposal in the early 1800s, in modern times at least, that atoms must exist. And over time, as more and more evidence piled up, more confidence piled up as well. And this is true in religion as well. In fact, Jesus compared the building of faith to a mustard seed. It starts out small, but as time goes by and we have more and more experiences, our faith grows like a plant. And it can, in fact, grow to be very large compared to how it started. So both in science and in religion, we can have faith that certain things exist and that the world is a certain way, even though we can't necessarily observe them with our eyes or other sensory organs. You might ask, well, why do people have faith? In religion, it comes about because we see evidence. It is the evidence of things not seen, as Paul said. Things like the voice of the Spirit, answers that we receive to prayers, and answers in Scripture to life's questions, and on and on. Also, we rely on the reports and testimonies from multiple reliable sources, people that we trust. People like the first presidency of the church, or missionaries, friends, parents, relatives, people we trust. We hear testimonies, and that reinforces our own belief. And finally, we have faith in religion because it's predictive and functional for creative action. Religion, the teachings of religion, our theology, the teachings of Jesus, lead us to do things that generate what we are looking for, namely happiness, peace, comfort, also hope in the future and an understanding of the world. These are all the fruits of the faith that we have. Bottom line is that we have faith because it works in that sense. What about atoms? What about science? Why do we have faith that atoms exist? Well, basically for the same reasons. Our experience is that believing in atoms is consistent with the evidence we have. And that evidence has piled up over the last couple of hundred years. There have been millions of experiments and other observations made of the physical world, and they're all consistent with the idea that atoms exist. And as time goes by, it's like building a puzzle. Each little piece adds new clarification, new clarity to our understanding, and new beauty to the patterns that we see in nature. Also, we have faith that atoms exist because we rely on the testimonies and reports from multiple reliable sources, millions of peer-reviewed journal articles, for example. And finally, having faith that atoms exist has been predictive and functional for creative action, the kind of creative action that leads to designing drugs and maybe even vaccines that we all hope for in the near future. And things like computers. I mean, we could make a list a mile long, couldn't we? Notice that faith in science and faith in religion come about by the same processes. But let's go back to atoms one more time and ask the question, can we really see them? In the end, I guess our faith in the existence of atoms would be rewarded if we could actually finally see one. Well, let's think about them though. What we've learned about atoms teaches us that they're very tiny. In fact, they're about this size. Now, it turns out that the limit of the human eye in terms of resolution is much bigger than that. Notice the comparison. And the limit, if we look through a light microscope, although the light microscope is able to help us see at a much higher resolution, it's still not good enough if you compare. It's still not good enough for us to be able to actually see an atom. In fact, we'll probably never be able to actually see an atom with our own eyes. And yet, the existence of atoms is so consistent with observation that we have a strong faith that they exist. I thought I'd just illustrate for you one fun demonstration that shows how we can use atoms to explain the phenomena we view in nature. What you're seeing here is called a flame emission. Methanol is burning, and as copper on the left or strontium atoms on the right are pulled up into the flame, their electrons are excited, and then when the electrons fall back down, they give off light of specific wavelengths. In the case of strontium, red, and in the case of copper, green. Makes for a nice Christmas decoration. Well, you can see that the consistency of atomic theory with what we observe in nature is illustrated here, as it is in so many other experiments. But again, just because our explanation of this phenomenon is consistent with the existence of atoms and structure doesn't prove once and for all that they really exist, does it? And that's why scientists very often are reduced to having to use what we call models in describing the world. Not this kind of model, but this kind of model here. You probably recognize this as a platypus. Now, the platypus was discovered in Australia a couple of hundred years ago. And when the people in Australia wanted to write back to their friends in England to tell them about the platypus, they had to do so by using what we would call models. What does that mean? Well, we often describe things that we can't see using features of familiar objects. Use the platypus as an example. A writer from Australia might say to his friend in England that a platypus is kind of like a duck because it has a bill. And it's also like a beaver because it has a tail like a beaver. And it lays an egg like a bird. So this idea of using models is also used commonly in science. And we talk about atomic models to describe the world. But that's not an exact description of an atom any more than calling a platypus a duck is a proper description of a platypus. A platypus is like a duck, and an atom, early on, people thought that they might model an atom like a solar system. In doing so, in describing the phenomena that we see in nature using models, we commonly call the model a theory. The theory, not in the sense that we're not sure that it's true, but in the sense that this is a way of describing what we see. So during the 19th century and during the 20th century, there were a succession of different models of atoms, how they're structured. And the model that the world is made up of atoms was continuously improved and became more and more accepted. So science used the atomic model to explain the world and how it works. What about proof, though? What about proof that atoms actually exist? That proof supposedly came along in the early 20th century because of a phenomenon called Brownian motion. Now, Brownian motion is very easy to understand. If you suspend little particles like pollen grains in water, and you look at them through a very powerful microscope like the one you see here, you'll notice that they tend to jiggle around. Now, the particles that you see in this demonstration here, you're seeing this through a very powerful light microscope, so you could see this with your naked eye. And these particles you see, excuse me, that you see are not individual atoms. They're little pollen grains. The atoms would be too small to see, but notice that the pollen grains are continuously moving around as if they were being bumped into by other things around them. This was considered by a famous scientist whom you all are familiar with. This is Einstein when he was younger. In fact, he looked almost normal back then, didn't he? He explained why these little particles underwent what was called Brownian motion, jiggling around like this, because the atoms that are so small you can't see them are also jiggling around, moving around randomly and bumping into the pollen grains, knocking them around, so to speak, and causing them to move in this way. So his explanation was that tiny unseen atoms were jiggling around and causing the larger visible objects, the pollen grains, to move around as well. And this, at that point in time, in the early 1900s, was considered the best proof so far of the existence of atoms. But notice once again, this is an indirect proof. It's consistent with the idea that atoms are there, but we can't actually see them with our eye. Fast forward to about 1980, and our faith in the existence of atoms was rewarded even better and turned into what some people consider knowledge. Again, not because we saw them with our naked eye, but because we used a machine, an instrument, a scientific instrument called a scanning tunneling microscope. Now, a scanning tunneling microscope works in a very different way from the microscope you're used to. You're used to a microscope that you look through with your eye, but this microscope, you don't look at with your eye at all. It works more on the principle, the same principle, as a record, one of the old vinyl records that are coming back into vogue today. They reproduce sound, as you know, as a needle, here's a needle, runs along a groove that has bumps in it. This is a magnification of the surface of this vinyl record. You see that these bumps cause the needle to jump up and down, and that is what creates or reproduces the sound. Well, this picture that you see here of copper atoms was created in a very similar way. A much smaller needle was run back and forth across the surface of a piece of copper. And as it did so, the surface of the atoms was revealed. So these bumps, these individual bumps, represent the individual copper atoms in this copper sample. This is probably, to date, the best proof that we have that atoms exist. Not because we saw them with our eye, but because our machines have made it possible for us to kind of map out how the atoms are arranged. And it's interesting that this very same technology can be used to move atoms around and place them in positions. So each of these bumps in this picture is an atom that has been moved around in such a way as to produce this Japanese kanji that actually says atom. Kind of interesting, huh? Well, I come back to the same question that I keep asking, and that is, are we really seeing the atoms in this case? And of course, the answer is no. We'll probably never actually see atoms with our eyes. They're so small that even one grain of sand contains a huge number of atoms. And in fact, you'll recall that we used grains of sand to illustrate how many stars there are in the known universe, more than the number of grains of sand on all the beaches and all the deserts. Well, what's even more fascinating is that there are almost as many atoms in one grain of sand as there are grains of sand on the Earth or stars in the known universe. So every one of those little grains of sand contains that many atoms. Well, if we wanted to see atoms, maybe what we should do is make a collection of atoms. Of course, if you bond atoms together, you probably remember this from your schooling, that you can make what are called molecules, which are collections of atoms bound together. This is one of my favorite molecules. It's called sucrose. It's really just sugar, the kind of sugar we eat in our food. Can we see this size molecule with our eye? Unfortunately, the answer is no, but we can taste it. That's true. Well, what if we were to choose a bigger molecule? A protein, for example, that has thousands of atoms. Could we see that? Unfortunately, the answer again is no. Even that is too small for us to see with our eye. We can use X-rays and machines, X-ray machines, to look at the atoms using a kind of light that we can't see with our eye, but we can't see the molecule with our eye itself. Now, the biggest molecule that we know of is the DNA molecule, which I'm sure you've heard of. There's a DNA molecule that makes up each of the chromosomes in a living thing like you and me in our cells. And it turns out that when a DNA molecule is wrapped in a certain way, bundled together, so to speak, you actually can see this molecule with a really good light microscope. But there are billions of atoms in a single DNA molecule.
Each chromosome contains a long strand of DNA, tightly packaged around proteins called histones. Within the DNA are sections called genes. These genes contain the instructions for making proteins. When a gene is switched on, an enzyme called RNA polymerase attaches to the start of the gene. It moves along the DNA, making a strand of messenger RNA out of free bases in the nucleus. Ribosomes bind to the messenger RNA. The messenger RNA is read 3 bases at a time. As each triplet is read, a transfer RNA delivers the corresponding amino acid. This is added to a growing chain of amino acids.
So I show you this because I'm always actually amazed at the complexity of all the things going on at the atomic level inside our bodies that we just don't perceive. We don't know they're happening, and yet this is what lies at the heart of what makes us alive. But what about DNA? It has billions of atoms in it. And in fact, if you took the DNA from one cell in your body, it would be 6 feet long. So you might ask yourself, well, if it's that big, how come we can't see it? The reason is because if you stretch it out, even though it's long, it's so thin, you just wouldn't be able to see it. But this is amazing to think that in all those little tiny cells, there is a molecule that is so big. In fact, there is enough human DNA in one human being, in one body, because we have trillions of cells with these DNA molecules in them. There's enough DNA to stretch from the Earth to the sun, and that's 92 million miles. 68 times. That is really astonishing, isn't it? Well, it's interesting, isn't it, that over the last couple of hundred years since Joseph Smith's time, we've come to understand so much about atoms and how they work, and yet we've never actually seen one. And kids learn about atoms and DNA already in grade school. And this fulfills a prophecy that I think is very interesting. Joseph Smith says in D&C 128, I should say the Lord says through Joseph Smith, those things which never have been revealed from the foundation of the world, but have been kept hid from the wise and prudent, shall be revealed unto babes and sucklings, in this the dispensation of the fullness of times. And in the teachings of the prophet Joseph Smith, he goes on to say, the dispensation of the fullness of times, when God will gather together all things that are in heaven and all things that are upon the earth, even in one. It's amazing how that has really come to pass, isn't it? And Brigham Young made the point that every discovery in science and art that is really true and useful to mankind has been given by direct revelation from God, though few acknowledge it. It has been given with a view to prepare the way for the ultimate triumph of truth and the redemption of the earth from the power of sin and Satan. So, the unseen world of atoms. There's one. Science, like religion, asks us to believe in things we cannot see, and that may seem counterintuitive. For as we lay the foundation for the remainder of our time together, we're going to make a list of all the invisible things that science asks us to believe in. And so we've spent a fair bit of our hour talking about the first one, and that's atoms and almost all molecules. We'll see a few more now in the next few minutes. More of what the eye can't see, but is being revealed in the dispensation of the fullness of times. This is a very interesting one. Did you know that you are swimming in an ocean of radiation and particles that you can't see or perceive in any way? I'll give you an example. You've probably already heard of things like protons, electrons, and so on. And as far as all the particles, including those and others in the universe, there are about 10 to the 80th. That's that many. And you know how, from our last lecture, you know how to interpret a number written that way, don't you? Well, to illustrate this next point, I'd like to invite you to hold out your hand. And I suggest that you actually do this while I point something out to you. As you hold out your hand, be aware that there is a kind of particle in the universe called a neutrino. Neutrinos are very small and they don't interact with normal matter like the matter in your hand. So don't be surprised that there are 4 trillion neutrinos passing through your hand every second, and you don't even know it. They have no charge and don't interact with normal matter. They have almost no mass, and they have no effect on us at all. In fact, they can pass through the entire Earth unaffected. They can pass through the sun unaffected. Why? Because they don't interact with normal atoms and the particles that make up normal atoms that in turn make up all the world that we live in. Neutrinos are so hard to detect that detectors for neutrinos are enormous. Here's a picture of one right here at the University of Tokyo. It contains 50,000 tons of water and is 1 kilometer underground. And despite its size, they feel lucky if they can detect 1 neutrino every day. Now, to just underscore how big this detector is, I'll blow it up for you here just a little bit. And I want you to see this object here in the background is actually a little boat in which 2 people are floating inside the detector to work on it. This is a far cry, isn't it, from the kind of telescope that was being used in Joseph Smith's day. And in fact, if you look at this, it's hard to believe that it's a telescope at all. But that is exactly what it is. This is a neutrino telescope. So there's another invisible thing that science asks us to believe in that we can add to our list. Fundamental particles like neutrinos. Okay, how about light? In Joseph Smith's day, he made the claim, there is no such thing as immaterial matter. All spirit is matter, but is more fine or pure, and can only be discerned by purer eyes. That's in Doctrine and Covenants 131. We're going to talk about light at length in a future lecture. But what about our impure eyes? Our impure eyes are able to see just a narrow band of the kind of light that exists in the universe. I'm sure you remember from your schooling that there are many other kinds of light: ultraviolet light, infrared light, X-rays, gamma rays, radio waves. But none of these were known until about Joseph Smith's time. Isaac Newton is famous here for his study of visible light, the kind of light that our natural eyes can see. In Joseph Smith's day, the philosophers, the natural philosophers and scientists of the day, believed in this slogan that we talked about earlier, and that is the idea that seeing is believing. But what about all the rest of the light that we can't see? Maybe it would reveal parts of the world, of the universe, to us that we wouldn't be able to see with visible light. In fact, since around Joseph Smith's time, we have come to realize that before then, we had been observing only a tiny part of all the light spectrum. And therefore, our ability to observe what there is in the world was very, very limited. What the eye can't see is the theme of our lesson today. And the answer is most of light. Most of the kinds of light that are available for us to observe the world are not available to us because our natural eyes are not able to see those kinds of light. Light, of course, is a key in science. We rely on light to help us see what's out there. And it's a key in theology, as we will see in a future lecture. These are, light is a key to unlock the mysteries of the universe, we might say. We will talk about that at length in lecture 5. So let's add most of light to our list of the invisible in science. Well, what else does science ask us to believe that we can't see? Oh, here's another pop quiz for you. Take 30 seconds and answer this question. Apart from the Big Bang, what's the biggest explosion in the universe? Well, I can tell you that it's not answer D. It's not a super duper hypernova. In fact, it is a hypernova. You might already be aware that a nova is a new star, and a hypernova comes about because it's a really bright new star, a star that has exploded, a big star, a giant star that has exploded. And when giant stars explode, they produce black holes. What is left behind after the explosion is a black hole. Now, black holes are very interesting, and I'm sure that you've heard about black holes before. What's inside a black hole? We don't know. Why? Because no light can escape. The black hole distorts space in such a way that light can circle around inside but never get out. there is a supermassive black hole at the center of each galaxy. What does supermassive mean? Well, it means that the black hole itself carries as much mass as millions or billions of times the mass of our sun. Up until just a few years ago, black holes were considered to be theoretical. But in fact, something's happened just in the last few years. How do we know that black holes exist? Again, we have pretty good evidence in the form of a picture taken in light by a number of telescopes simultaneously. But what's interesting about this picture, even though it is considered the first picture of a black hole taken in 2017, is that you don't see the black hole itself. You only see the light that comes from the material around the black hole. The black hole itself is invisible because by definition, light can't escape from a black hole. This particular black hole is 53 million light years away from us. It's at the center of a distant galaxy. We know that it can't be in our galaxy because our galaxy is only 100,000 light years across. So what's also interesting about this particular black hole is its mass. It's huge. It has the mass of 6.5 billion suns. We know then that black holes exist if we can't really see them. Well, what we can see is their effect on the material around them. For instance, we know that there is a black hole at the center of our galaxy because the stars in that region are moving in such a way, at very fast speed, that can only be explained in terms of a black hole. How big? A black hole that is 4 million times the mass of our sun. Now, we can't see black holes, but again, we're expected to believe that they exist. There are good reasons, because what we do observe is consistent with the idea that there is a black hole there. But once again, we're relying on indirect evidence. We have not seen the black hole itself. Here's a good cartoon about black holes. It's a black hole. Wait, what's all that debris? It looks like, hey, it's my letters to the editor and my movie script submissions and all the ideas I've ever put in the suggestion box. Well, of course, this cartoon doesn't really relate to reality because you can't actually see a black hole by looking through a gigantic telescope like this. The pictures that are taken of black holes are typically made with instruments that are much more sophisticated than that. But at this point, we can add black holes to our list of the invisible in science. The next point has to do with models of gravity. You'll remember that Isaac Newton, famous for his using an apple as a model for the interaction between the Earth and the Moon, came up with the idea of gravity being a force. There was a problem, however, with this idea. And even though we talk about the force of gravity still today, scientists don't believe that there is such a thing. There is no such thing as the force of gravity. Why? Because this idea involves what's called action at a distance. There is no material between the Earth and the Moon to generate a force that we could perceive. And this seems a little like magic and was a problem that scientists wanted to resolve about 100 years ago. And guess who solved that problem? The same man we talked about earlier, Albert Einstein. But his solution was to propose that there is a fourth dimension of space or space-time. We'll just stick with space. A fourth dimension of space. How did this solve the problem? Well, before last week's lecture, you had a chance to start thinking about the fourth dimension. You saw a video in which Carl Sagan described a thought experiment. A thought experiment in which we imagine that we live in a two-dimensional world, not a three-dimensional world, but a two-dimensional world. It's as if we were little squares or circles living inside a piece of paper. So we live in a flat sheet of paper, and we can imagine that there might be a third dimension, but we can't see it anywhere. We can imagine also that the paper can bend into the third dimension, even though because we are in the paper, we can't perceive that it is bending. So I'm going to ask you to revisit that video next week because we're going to talk at length about this then. But just to illustrate how this belief is a request, an asking, if you will, of science that we believe in something we can't see, let me just carry through the logic here very briefly. Now, if we were two-dimensional people in a two-dimensional world, how would we be able to tell that there is a third dimension? Well, one of the ways is that we could see how light moves around a heavy object. Because light, you see, can't be attracted by gravity. It has no mass. So if there were no sun, there were no massive object in the space through which the light was traveling, the light would travel in a straight line. But let's imagine that there is a heavy sun. Now, this is a two-dimensional sun, not a three-dimensional sun, inside this piece of paper. And it's so heavy that it warps the paper into the third dimension. If that were true, we would observe the light not travel through a straight line, but through a curved line. And by following the curved line, we would know that there had to be a third dimension. Now, we can extrapolate this thought experiment into our real three-dimensional world and imagine that there is a fourth dimension. How would we tell if there is a fourth dimension? We would ask ourselves, does light curve around a heavy object? Well, it turns out an experiment was done and it was found that indeed light does not follow a straight path around the sun, but light that travels close to the sun follows a curved path. So from that, Einstein deduced that a fourth dimension must exist. We can't observe it, but we can deduce that it must exist. If this blows your mind a little bit, that's perfectly okay. We're going to talk more about it next lecture, and as time goes by, hopefully it'll feel more familiar. But we're going to add the fourth dimension now to an additional item that science asks us to believe in that we can't see. But you know, guess what? What we've talked about so far is only the tip of the iceberg when it comes to what science asks us to believe. In the latter part of the 1900s, the 20th century, it was decided by science that the universe must contain a large amount of what's called dark matter. I have a picture for you here of dark matter. What's interesting about dark matter is that we know nothing about it other than that it exists. And this may seem paradoxical to you because we can't see it or perceive it in any way. We don't know what it is. We don't know, let's see, the question arises then, excuse me, how do we know that it's there? We know that it's there because there's much more mass in the cosmos, much more material in the cosmos than all the matter we can see with visible light, or any kind of light. You see, there isn't enough matter in the stars and the planets in any galaxy to hold the galaxy together. The galaxies, any galaxy that doesn't contain dark matter must fly apart. So even though we can't see the dark matter, we know that there is matter there that is exerting gravity on the stars in the galaxy to hold it together. Also, the amount of gravity, the amount of mass that produces gravity in any given galaxy is enough to bend the light coming from behind it towards our eyes to form these interesting patterns. It's called gravitational lensing. This pattern that you see here is actually the distorted view of a galaxy that is behind these galaxies. But because of all the matter in these galaxies, the space, according to Einstein, is warped in such a way that when the light passes by these galaxies, it is bent and forms these interesting shapes. These shapes that indicate that there is much more mass in these galaxies than we can see of material that is there. So, because of this kind of indirect evidence, scientists have concluded that there must be a huge amount of matter in the galaxies that we can't perceive. What about dark matter? It doesn't interact with ordinary matter at all, except that it exerts gravity. It doesn't interact with you and me because we are made of ordinary matter. And as a result, it's possible that a dark matter dinosaur could waltz through this room right now and we would. Now that dark matter dinosaur could waltz through not just the room, but through me, through you, through the furniture, and it would have no effect on us. We would have no sense that it was there. This is according to science. So let's add dark matter to our list of invisible things in science. But, there's more. Dark energy. In the late 1900s and in the 2000s, we've come to believe, we meaning the science community has come to believe, that there is a huge amount of what's called dark energy in the universe. In fact, even more dark energy than dark matter. Dark energy is proposed to explain a very interesting result that has been observed in the universe just in the last few decades. It is, well, you'll remember that we talked in the last lecture about how the universe is expanding. That was learned in the 1920s. But recently we've come to understand that it is expanding faster and faster as time goes by. Dark energy is proposed to explain this. It's kind of like the opposite of gravity. You know how gravity tends to pull things together. Well, dark energy would be the energy necessary to push them apart because in fact, galaxies are moving apart faster and faster as time goes by. Now this is the interesting graph as we currently understand of the makeup of material in the universe. What is the universe made of? It turns out that the atoms that make up you and me and the earth and the sun and all the planets and the stars, turns out that they must make up only about 5% of all the material that there is in the universe. Dark matter takes up about 24% of the matter in the universe, and dark energy makes up the bulk, most of what is in the universe. And it's astonishing to think that most of the universe, more than 90% of the universe, is made up of material that we cannot see, hear, taste, smell, or touch in any way. That is according to modern science. Dark energy, there it is. We can't see it or perceive it. We don't know what it is, but it accounts for much more mass energy in the cosmos than all the matter we can see, plus all the dark matter we don't understand and can't see. So let's add dark energy to our list of things that are invisible in science. And we could add even more, but we've run out of time. What are we expected to believe? Well, we're expected to believe that these things exist for good reason. We should have faith. Our belief in these things and our faith in these things is not blind. That faith comes about because a great deal of indirect evidence points to the fact that these things must exist. Science has changed over time. In Joseph Smith's day, the adage was, if I can't sense it with a body part, it doesn't exist. But in the 20th century, we came to rely more and more on our instruments, our machines, our scientific machines, to sense what is out there. And we came to believe that if I can't sense it with my body or with a machine, it doesn't exist. Now in the 21st century, we're asked by science to take it on faith that some things exist simply because logic says they must exist. How do these compare to those claims made in science, made in religion, such as the existence of God, the existence of angels, heaven, outer darkness, the spirit world, or spirit matter? The fact is that we have faith that these things exist, that it is not blind faith, but we have faith because there is good evidence, as I explained earlier in the lecture. So to sum up, natural science and theology share this in common now. Wasn't true in Joseph Smith's day, but it's true now. They both ask us to believe in things we cannot see, and for good reason. So in Joseph Smith's day, religion asked us to have faith in the existence of an unseen God, a spirit world, angels, and so on. Science believed that if we couldn't see it or sense it, that it must not exist. How that has changed over the last 200 years. That now that conflict has been resolved. In the latter days, both science and LDS theology teach of worlds hidden from our natural senses, but that we believe to be as real as anything we can perceive directly. So normally, I would end the lecture with a hymn, and I'll go ahead and play that briefly, but it does bring to mind, does it not, how in the latter days, the visions of old are returning and angels are coming to visit the earth. At this point, I think perhaps because of time, we should go ahead and close.
Spirit of God, like a fire is burning.
So thanks for listening, and Brother Ugo, if you'd like to close the lecture tonight, that'd be great.
All right. Ok, grazie a tutti per essere stati qui questa sera. Credo ci sia tempo, se volete, per una o due domande. Se c'è qualcuno che vuole chiedere qualche cosa, altrimenti possiamo chiudere con una preghiera. Qualcuno?
Io ho una domanda.
Ecco qua, grande Davide, vai.
Sì, volevo sapere, meglio se la faccio in inglese?
Come vuoi tu.
Oppure in italiano va bene anche.
Ok, perfetto. Nella scienza, quando qualcuno dice qualcosa che va contrario a quello che si conosce, oggi lo vediamo specialmente nella medicina, dove per esempio ci sono tante persone che non vogliono vaccinarsi, la reazione della comunità scientifica è abbastanza dura, e penso che se noi siamo coerenti con quello che crediamo, diciamo, dobbiamo allinearci con la scienza. In che modo questo poi si trasporta nella religione? Nel senso, noi crediamo qualcosa nella scienza, diciamo, e le opinioni che vanno contrarie ai risultati che abbiamo avuto non le rispettiamo, però diciamo nella religione sì, quando abbiamo qualcuno che crede in qualcosa di diverso di noi, lo rispettiamo. Quindi in che modo diciamo, le due cose vanno insieme? In che modo dovremmo rapportarci con le persone che hanno una religione diversa? Cos'è che dovremmo pensare?
Well, I will answer in English. I think that the correct answer is that we should love them. You know, part of the reason for this lecture, part of the objective of the lecture was to illustrate, for us at least, how science and religion really aren't that far apart in terms of asking people to believe in things that are very difficult to understand and believe unless you have some personal reason. In religion, we have evidence of things unseen, just as Paul told us, is faith. And by the same token, nowadays, perhaps unlike Joseph Smith's day, science asks us to believe in things that are just as difficult to understand and believe, and yet they, and we, I think too, believe that they are real. I think that the best way to deal with people who disagree with you is to offer them respect for their point of view, but help them understand in a kindly way that their set of beliefs isn't all that different from ours in the ways that I tried to illustrate tonight.
Grazie.
Okay.
Qualcun altro? Ok, allora chiudiamo qua. Vediamo un po' chi può fare la preghiera. C'è così tanta scelta. Giulia Marinello, ce la fai tu? Visto che c'è la webcam accesa e ti vedo.
Certo, con piacere.
Aspetta, anche in italiano va bene?
Va bene. Caro Padre Celeste, siamo davvero grati per questa serata e siamo grati per l'opportunità che